Hello everyone, my name is Preston and I'm currently enrolled in the Computer Organization course taught by Professor Ali at the Florida Institute of Technology. I'm here today to talk to you about firewalls and their importance in network security. I'm going to start off with a brief history of firewalls, describe how specific types of firewalls operate, give you the current state of firewalls and network security, and then finish up with a review and assessment of companies leading the way in advanced capabilities. Most of you have heard of the WannaCry ransomware attack, the massive data breach of Equifax, and the Yahoo email hack. These are all examples of present vulnerabilities in computer information systems. And I believe that firewalls are the first line of defense in network security. So let's get started. Firewall overview. So firewalls were originally designed by the Advanced Research Project Agency Network, better known as ARPANET, and they have been around since the late 1980s and have continuously evolved since their inception. The etymology of the term firewall comes from the definition of a physical firewall that keeps a fire from spreading from one area to the next. An example of this is a firewall in an automobile that separates the engine compartment from the passenger compartment, which you can see in the photo on the right. The firewall in an automobile blocks fire from accessing the passenger compartment and causing damage if something terrible were to happen. The same is actually true for computers, where the firewall blocks access to the host computer from the outside internet and potential threat. So in computer security, firewalls were developed as a method for allowing or restricting outside access to particular network resources. Firewalls are currently capable of enforcing the company's network security policies, logging internet activity, and securing an organization's exposure to outside threats as it relates to protecting critical assets. As you can tell, there are a multitude of benefits that firewalls add to a network security layer. Next, we'll talk about the types of firewalls. So there are two types of firewalls, software and hardware. Each type has its own unique benefit and purpose in the terms of firewall utilization. Therefore, it is important to understand and implement both types in order to maintain network security. So first we'll discuss software firewalls. These are also called host-based firewalls, which are installed on a host. The software provides a service to a specific host and offers the convenience of cloud-based updates and intrusion detection. A prime example of a host-based firewall is a Windows firewall. This has the capability of a host-based intrusion detection system, better known as HIDS. The intrusion detection system gives the user the ability to monitor and detect malicious activities. One of the advantages of using an HIDS is that it can interpret encrypted traffic. However, some of the disadvantages include its purchasing price, the intensive operation, and its local storage database. Next, we'll talk about hardware firewalls. Hardware firewalls, or network-based firewalls, are typically implemented in a hardware device or built into a router that is accessed on the local area network. Hardware firewalls fall into two basic categories: small office, home office, and network-based. Small office, home office firewalls are built into most consumer-grade routers, whereas network-based firewalls are implemented at the hardware layer. Hardware firewalls perform well at protecting the whole network. However, they fall short in providing any help if the malicious traffic is originating from inside the network. It's deduced that the combination of hardware and software firewalls is an optimal strategy. As cyber threats continue to persist, firewalls have also progressed with advanced technology and functionality, which we'll talk about next with the types of firewall operations. So initially designed to filter packets, firewalls have evolved to include a variety of additional requirements and security goals necessary to combat threats and increased level of sophistication hackers currently impose on large organizations. So originally designed to filter packets, packet filtering is a firewall technology that makes decisions based on packet header values. The header values reside on the network layer of the Open Systems Interconnection model, which you can see is layer 3. Packet filtering was the first generation of firewalls and is the most rudimentary type of all the technologies. The greatest benefit of packet filtering is the filter's ability to look at the packet header at the network layer and make a decision based on criteria. Some basic criteria include the following: source and destination IP address, source and destination port numbers, protocol types, and inbound and outbound traffic direction. An important task of packet filtering is implementing an access control list, or ACL, which is enforced at the network interface layer. The known device carrying out the packet filtering applies a basic ACL on the incoming traffic. An ACL is pretty much a set of rules that applies to a specific set of network names, IP addresses, and port numbers. So for example, if you wanted to allow standard web traffic from system 1.1.1.1 to system 5.5.5.5, you can use the following ACL. Permit TCP host 1.1.1.1 host 5.5.5.5 EQ www. So basically, ACLs can explicitly allow or explicitly deny traffic, and ACLs can also offer the ability to implicitly deny any network traffic and not defined in the network's firewall rule, both of which are predicated on the system's desired outcome or security policy. So packet filtering is also known as a stateless inspection firewall. Stateless inspection refers to the firewall's inability to retain the state of information of the individual's packet that passes through the firewall. So pretty much stateless firewalls make decisions solely based on the data within the packet, which could cause stateless firewalls to be more vulnerable to IP spoofing attacks. So alternatively, we have stateful inspection, which actually remembers and keeps track of the full communication packet, crazy enough to believe. So by being able to remember the entire packet, stateful firewalls are less susceptible to IP spoofing attacks. While stateful inspection firewalls are scalable, they're transparent, and they provide an extra step of protection, this firewall does have its own drawbacks. And two of those major drawbacks include the flooding of information to cause a DOS attack or a denial of service attack, and then the connection complexity because it remembers all those connections. It can actually overload the system and cause the device to freeze. Next, we have proxy firewalls. Proxy firewalls are really kind of cool because they're established between a trusted and an untrusted network. It's almost like a middleman. And the connection that's established on behalf of each source. So, one of these important characteristics of a proxy firewall is the fact that there's actually no direct connection between the two sources, which is important because where packet filtering actually monitors the traffic on network connection, the proxy firewall actually starts and ends the connection on behalf of the sending and receiving system. And there's pretty much two basic types of proxy firewalls. We have the circuit level and the application level proxies. So a circuit level proxy works at the session layer of the OSI model, which we can see is layer 5, and it doesn't conduct deep packet inspection because the proxy does not inspect at the packet level. It can provide a broad range of protection against the threat because it does connect two communication systems together, which is an important concept for circuit level proxy. So similar to packet filtering, the circuit level proxies allow or deny communication based on three different criteria, which is the address, the port, and then the header values. More effectively, another option of the proxy firewall is the application level proxy, which works at the application layer, and it makes decisions based on the packet content. So a great benefit of the application layer proxy is the ability to comprehend an entire packet and various protocols associated with the communication transmission. Because it does work at the application layer, it can distinguish between the protocols such as FTP, HTTP, and SMTP, among a list of other ones. So it gives it an ideal choice for network security. So proxy firewalls, they have their attributes and characteristics. However, there's other different types as well, depending on the business needs. For instance, we also have dynamic packet filtering firewalls. This type of firewall is predicated around the fact that when an internal system needs to communicate to an outside source, an actual port is established to the receiving system knows where to respond. And this is going to include a high numbered port because most of those smaller ports are used for other things. And then it also includes the ACL, the access control list that we talked about earlier. They're created together to propagate messages from the external system to the internal entity. So it's really kind of cool because it gives you the option of allowing any type of traffic outbound and permitting only response traffic inbound. So it kind of limits that communication between those depending on what security rule is established by the administrator. And last but not least, we have the kernel proxy firewall. This functions also at the application layer. So once a packet actually reaches the firewall, a virtual network is created that is made up of proxy protocols. So the benefit of a kernel proxy firewall is the multiple OSI layer functionality, and then it also has a higher processing power due to the fact that processing actually takes place in the kernel, and it doesn't require any additional handling by the operating system, which is a great benefit. Lastly, another benefit of the kernel proxy is that it discards packets during transmission if the information is deemed unsafe. So at any point in the transmission, if something's deemed unsafe, it discards that. Whereas in some packet filtering, it actually keeps that information for the entire time. So that is an additional benefit of kernel proxy firewall. And that pretty much sums up firewall operations and how they flow in terms of the packet information coming through. And next we'll start talking about some newer technology that's coming into play and benefiting the current network security environment. So as we mentioned, professional hackers are becoming more sophisticated, so large organizations must possess the tools and resources necessary to combat those threats. So now what companies have started to do, they've almost tried to mesh technologies together. They've been looking towards these new generation firewalls, which they call the next generation firewall, or NGFW. And this actually provides additional components and capabilities that really put their network security in top notch. So part of the next generation firewall is the IPS, which is the intrusion prevention system, and it's the ability to examine network traffic flows to detect and prevent vulnerability exploits. And an IPS, it differs from an intrusion detection system in that it prevents intrusion and exploits, whereas a detection system pretty much is just a passive system that scans traffic and reports back on threats, but it doesn't really do anything about it. So the NGFW is a type of firewall that has the ability to spot certain indicators of a potential attack, even in an otherwise normal traffic. And then coupled with the capability of connecting to external data, the next generation firewall is an optimal firewall technology for large organizations. So this feature, it allows for consistent settings to achieve on multiple firewalls looking on the network. So it is really beneficial for those larger organizations. Unfortunately, because of the cost, small and medium networks don't really benefit from the next generation firewall. So we also have another new concept, which is the unified threat management. It's been introduced in the field of network security, and it's proven to be cost effective in managing the plethora of solutions that are needed to combat the ever-present threats that organizations face. So the UTM, or Unified Threat Management, it's a system that combines numerous devices to create an all-in-one solution, which is used to actively execute countermeasures. So the UTM works as a single source device placed on a network prior to a connection to the internet. So this all-in-one device really combines the tasks of firewalls, IPS, content filtering, and other solutions, but the function and capability, they do depend on the respective supplier. So it all depends who you go through in order to get the specific UTM. But one can really infer the benefits of such a device on a network and the value-added activities resulting from the implementation of a UTM. But one cool benefit of the UTM is they use the GUI, a graphical user interface, to provide a streamlined approach to network security. So it really makes it easier for any kind of network administrator to really assess and investigate potential attacks. Unfortunately, like most things, there are weaknesses to a UTM products. Some of those weaknesses include there's a single point of failure for traffic, there's a single point of compromise, and then there's obviously performance issues when you're running so many programs at once. So by using the UTM as a single point of defense, once a hacker penetrates the UTM, the system pretty much is compromised. So whenever you do look for UTM as a solution, it's advantageous to also deploy some other layers of security just for protection. And then you also want to look at the performance of the UTM because whenever you're adding on additional things, performance can slow. So what we'll do now is we're gonna look at some companies that are providing certain technologies and go from there and see which one would benefit your business. So leading the way in some advanced technologies, the UTM and the NGFW, there's companies such as Cisco, Palo Alto, and Fortinet. Clearly, there's a lot more organizations out there and a lot of businesses doing a lot of great things in terms of network security. But for the purpose of this video, I'm going to go into these three companies and talk a little bit about what they're doing now they're combating that persistent threat. So Cisco has been around since 1984. They offer an array of products in conjunction with a number of service offerings. They're highly reputable. They do business globally. I really value their vision to deliver a high, secure, intelligent platform for digital businesses. So I really can buy into what they're doing. So Cisco's portfolio really focuses on solutions that cover network security, policy, and then the UTM. So their solutions are designed to increase capability while reducing complexity, which is also an added benefit to increase the security efficacy. So one of those solutions that they've come out with is the advanced next generation firewall, the NGFW we've been talking about, and it's the Cisco Firepower 2100 series. It's that picture on the top left, which it's a firewall. It has an IPS system, URL filtering, as well as some incorporations of the UTM. So the 2100 series, it provides the network security through the execution of the firewall and threat inspection functions. So this helps really maintain a system's network and has the added benefit of continued performance. It's a threat-focused solution which benefits businesses that are looking to act fast. According to Cisco's annual security report, there's a 100-day medium time from infection to detection, and Cisco really boasts of the fact that their next generation firewall can reduce that detection time to less than a day. So with that firewall as well as the UTM, I think this could be a great investment for a business that's really looking to provide some additional network security. So next we have Palo Alto. This company has been incorporated since 2005. They're a technology firm that provide innovative solutions to meet the cybersecurity needs of organizations, which I can really buy into. Their platform offers superior performance compared to legacy approaches, and the fact that what they're trying to do is eliminate the need for multiple standalone security applications. They want to be more of a software in the cloud kind of approach. But what they do have is their major next generation security platform, and it consists of three elements. So you have the next generation firewall, an advanced endpoint protection, and then a threat intelligence cloud. So the next generation firewall is the core of the platform, and it's used to inspect all the incoming and outgoing traffic from malicious activity. Then you have the advanced endpoint protection, which is a software that's used to prevent cyber attacks running malicious code on a variety of endpoints and servers. And then lastly, you have that threat intelligence cloud at the top that's used to provide security for service, software as a service, that SaaS applications. So as part of the platform, Palo Alto offers a number of subscriptions to increase the efficiency and reliability. So they have the same subscriptions as Cisco, where you have that URL filtering. They have their own little Wildfire and Global Protect, which are different options that are available to enhance the firewall applications. So Palo Alto, they currently operate on the rationale that legacy firewalls, older firewalls, use a layered security approach to firewall architecture. And they think those are antiquated and inefficient. But Palo Alto believes that their next generation firewalls, these ones use a unified security design, give them that competitive advantage over their competitors. So I think that software as a service leverage coupled with the subscriptions makes Palo Alto the desirable choice for businesses when it comes to selecting a company to provide cybersecurity needs at the network layer. So next we have Fortinet. Fortinet is a global leader and innovator in network security. They also provide some cybersecurity platforms to large organizations, and they offer products with single source threat intelligence as well as integrated network security architecture. Um, they currently use patented cybersecurity advancements to provide organizations with an extensive range of security products and services. They have firewalls, advanced threat protection, and a UTM, which they boast as their core competencies and revenue generating for the organizations. So as part of those competencies, they also offer a network security solution known as the FortGate, which you can see in the center of the picture on the slide, highlighted in that red outline. This can be deployed on most firewalls and clearly most next generation firewalls. This is an award-winning firewall that provides a multi-layered and advanced security over the entire enterprise network. The really cool thing about this solution is that it offers a high-performance security processing unit. It's a new technology that is established for the accelerated processing of security and network functions. This architecture it's comprised of circuits that's used for computationally intensive tasks such as firewall policy, network address translation, and IPS. So this is really cool because it's scalable for large institutions, which can ultimately reduce the cost for ownership and complexity. So Fortinet believes that with their FortGate technology, their next generation firewall can disrupt the network security market. One drawback for Fortinet is the fact that the company sells solutions to channel partners and then they sell to the end customer. So that's a little bit of a challenge, but their solutions are applicable for an enterprise of any size. So I definitely think they are a contender for network security in today's day and age. So when it comes to network security, there's a multitude of companies providing the most advanced and enhanced technology and securing an organization's assets. We've mentioned a few with Cisco, Palo Alto, and Fortinet. They all provide high quality and efficient products to the end user. However, there are some differences in their capabilities. For instance, Cisco, they promote the next generation firewall as a platform which can reduce the detection time to less than a day. The next generation firewall coupled with the UTM is an investment that integrates multiple security functions and provides protection to the end user. And then for Palo Alto, the company believes their next generation firewalls, the ones that use that unified security design, give them that leverage over the competition. And lastly, Fortinet's award-winning FortGate next generation firewall provides multi-layered and advanced security over the entire enterprise network. So you can deduce these companies all provide a unique approach to network security. It's ultimately up to this decision of the company and its shareholders to decide on the direction the company wants to take in providing network security. However, I do want to leave you with these final thoughts. Did you know that there's more than 23% of organizations have vulnerabilities dating back to 2011, and then that average cost of a breach is $1.57 million. So as I mentioned earlier in this presentation, there's the WannaCry ransomware attack, the massive data breach of Equifax, and the Yahoo email hack. This just reveals that organizations are more critically exposed than ever. A value-added activity such as a firewall, it doesn't necessarily create revenue. However, it is a wise business investment, and I believe that if organizations sit idly by and do not follow the principle that it's not a matter of if but when, a business may fall victim to cyber attacks. So we talked about the types of firewalls earlier in the presentation, where we broke it down into software firewalls and hardware firewalls. And right now I want to focus a little bit on software firewalls. Those are those host-based firewalls that are installed on a host. I mentioned that the Windows firewall is a prime example of a host-based firewall. It also provides that host-based intrusion detection system. So I wanted to just show you where that is on your system, so you can be able to check it out, see if you're connected, and if you want to make any rules, any changes, and you have the administrative function to do so, you'll have that ability to know where that is on your computer. So what you're going to do, you want to go to your Start menu, go ahead and click on your Control Panel, Once that pops up, you're going to go to the top of your screen and go to Systems and Security. And here, right below the Action Center, you'll see Windows Firewall, where you'll be able to check the firewall status and you can allow a program to a Windows Firewall. You want to go ahead and click that Windows Firewall. So here you have your Windows Firewall where you can check your connection, you can see when any rules are set up, and then see if you can allow any notifications or anything to come through the network. So here we have our network at home, where I currently am. You can have your firewall, window firewall state, which is currently on. Your incoming connections, you're going to block all connections to programs that are not on a list of allowed programs. And then you have your program, your private network setup, and then your notification state, where it's going to notify you when Windows Firewall blocks a new program. So this is pretty much where you can get a rundown on your firewall and your current connections. And then if you want to make any changes, I recommend if you're going to make any changes, you do so knowingly and willingly that something could end up impacting and coming through that could impact your system. So what you want to do is you want to click on this Allow a Program or Feature through Network Firewall. So what you want to do is roll down, you'll scroll, and you'll see that there's different types of programs and features that are being allowed or not allowed. And if you want to change the settings, you go in and you change. And now you'll be able to go in and allow or unallow program. Like I said, I highly recommend you do this knowingly and willingly that something could change. So let's go ahead and get back out of that. You can also go in and change your notification settings. You can go in and turn firewall on or off. And you can customize that if you would like. You have the ability to restore defaults, advanced settings, and then troubleshoot your network. So this is a basic tutorial of how to access your Windows Firewall and the ability to make any changes.